Problem number 3. In quadrilateral ABCD, the length of AB is 4. So let's just draw that on there. BC is 12. CD is 2. And DA is 8. And the length of BD is an integer. Alright, that's this diagonal across the quadrilateral. And we're asked, what is the length of BD? Well, you might be thinking, well, I don't, how in the world can you figure that out? But the key is that it's an integer. And the other key to this problem is something called the triangle inequality theorem. Triangle inequality theorem. Okay, and the triangle inequality theorem just says that the sum so it says that the sum of any two sides of a triangle is greater than the third side. Okay, so let me write that out. The sum of any two sides of a triangle is greater than the third side. Okay, or the length of the third side. Okay, so and that kind of just makes sense, right? Because if you have a third side, we'll call this the third side, and you have two other sides attached to the corners here, and if those two sides don't, if they're not long enough to reach all the way across that third side, you could swing these legs of this triangle, or well, not a triangle, these legs around, and they'll never meet up to form a triangle. You can't do it, right? So you'll never get a triangle out of that. And if they happen to be equal, then you'll end up getting a flat thing, right? So they'll end up meeting, but they'll end up meeting, in the middle of somewhere in the middle of the third side. So they have to be greater than. The sum of these two legs of the triangle has to be greater than the third side. So it's kind of intuitive if you think about it. And we can use that in addition to the fact that the side has to be an integer to figure out the answer to this problem. Alright, so let's take a look at what the triangle inequality theorem implies for this quadrilateral. So we have a triangle here, ABD, alright? We know two sides. So we could write that 8 plus 4 has to be greater than BD, which is the side we're trying to figure out. We could write things like, we could write BD plus 4 has to be greater than 8. So what would that imply? That would imply that BD is greater than 4. This, of course, implies that BD is less than 12. Okay, if I just reverse this inequality around and then add 8 and 4 together. Let's see. So then let's look at the other one, the other triangle. We could also look at, BD plus 8 has to be greater than 4. We could write that out as well. But let's look at this other triangle, because we can look at 12 or 2 plus 12. It has to be greater than BD, right? So essentially, 14 is greater than BD, or if we switch that around, it's BD is less than 14. Well, we already know that BD is less than 12, so that doesn't really give us any new information. This is more limiting. So let's look at some more of the inequalities on this triangle. So we could write that, well, let's just write BD plus 2 has to be greater than 12, which implies that, what, let's see, yeah, BD plus 2 has to be greater than 12, so that implies that BD has to be greater than 10, okay? Well, now that's more limiting than this one. Here we have BD is greater than 4, so we don't really have to worry about that. So we've got it down to BD is greater than 10 and BD is less than 12. So that's the key here, because the only integer between 10 and 12 is 11. So that means that BD has to be 11. Okay? Because we're told that it has to be an integer. And given the triangle inequality theorem, it has to be between 10 and 12, which is 11. So there you go. That's the answer to the problem.